Alright, this next video, we're going to continue talking about our quadratic functions and models. And in this particular video, we're going to discuss how to transform from vertex form to standard form and vice versa. Okay, the first one is the easiest. It's the one that it's very straightforward. So remember that vertex form is f of x equals a times x minus h squared plus k. We have standard form is f of x equals ax squared plus bx plus c. And so to go from vertex form to standard form, basically what we want to do is we just want to get rid of the parentheses and then combine like terms. So we are going to start by squaring the binomial. We want to distribute the outside number to all terms, and then we want to combine the constants. All right, the other one that we have is we want to talk about converting from standard form to vertex form. We're going to use the shortcut in this section. In the next section, we will talk about how to do it mathematically like we do from going from vertex form to standard form. But we're going to take the shortcut this time around. And the first thing that we want to do is we want to use our formula for finding the vertex. And remember, our formula for the vertex is we use negative b over 2a to find the x-coordinate. And then we plug that back into our function to find the y-coordinate. From there, we're going to take these two values, our x and y coordinates of our vertex, and our leading coefficient to plug them into our vertex formula. All right, so let's go ahead and look at some examples and see how this works. Okay, so for example A, we want to write the function in standard form. And then we're going to go ahead and find the vertex for both equations and convert that they are equivalent. We also want to identify our leading coefficient. All right, so the first thing that we want to do is we want to go ahead and square the binomial. Now remember that we do not distribute the square. What we have to do is we do have to FOIL. So we want x minus 4 times x minus 4. We still have our 1/2 over here, and we still have our plus 3. All right, so if we go ahead and FOIL, we want to multiply our firsts. We get x squared. We want to multiply our outsides. We get negative 4x. We multiply our insides. We get negative 4x. And we multiply our last. We get positive 16. I'm going to put this all in parentheses because, again, we do have that 1/2 on the outside that we are going to have to distribute. And I'm going to go ahead and bring down my 3. All right, if we combine our like terms, inside, we have x squared minus 8x plus 16. We still have our 1/2 on the outside, and we still have our plus 3. We want to distribute to get rid of the parentheses. And so 1/2 of x squared is just 1/2 x squared. If we take half of negative 8, we get negative 4, and we keep our x. And if we multiply half times 16, we get plus 8. And then we still have our plus 3. And so when we finish this off, we want to go ahead and combine our constant terms now. And so we get 1/2 x squared minus 4 plus 11. This is our function. Okay, so now just to confirm that this is the correct function, we want to make sure that we have the same vertex. And so we're going to use our vertex formula on this new equation. Remember, for this we want x is negative b over 2a. And so if we plug this in, what we get is minus negative 4 becomes positive 4. And then if we multiply 2 times 1/2 or 0.5, this one's going to go away and we just have a 4. If we go ahead and plug in 4 to our function, we get 1/2 times 4 squared minus 4 times 4 plus 11. All right, if we square the 4, we get 16. And half of 16 is 8. If we multiply 4 times 4, we get minus 16. And if we combine this, we get 8 minus 16 is negative 8, plus 11 is 3. And so for this version of our function, we are confirming that our vertex is 4, 3. And that's exactly what we have up at the top. Remember, we changed the sign of the middle of the inside number because it says minus 4. That means my x coordinate is 4. And we keep the sign of the outside number, and so this is going to be 3. It also asks us to, what is our leading coefficient? And for both of them, it doesn't matter whether you are in vertex form or standard form, our leading coefficient for this one is 1/2. We get the 1/2 here from our function, and it's the same thing as this number that is on the outside in our vertex form. All right, so that is going from vertex form to standard form. The next thing that we want to do, the next examples that we're going to look at, is we are going to start out in standard form, and we want to go backwards. We want to rewrite it in vertex form. All right, for our next examples, we want to go the other direction. Again, we're going to take the shortcut for this. So for instance, we want to start by finding the vertex using our vertex formula. And so for example A, if we go ahead and plug into our vertex formula, we have negative b over 2a. If we plug in, we get negative 12 is our b value, and a is 3, and so we get negative 12 over 2 times 3. If we simplify this, we get negative 12 over 6, which is equal to negative 2. All right, we want to go ahead and plug this into our function. And so when we do this, we have f of negative 2 is equal to 3 times negative 2 squared plus 12 times negative 2 plus 7. All right, if we square negative 2, we get 4. And if we multiply 4 times 3, we get 12. 12 times negative 2 is negative 24 plus 7. And when you simplify this, you should get negative 5. And so that's what we have. We have our vertex is negative 2, negative 5. And remember that we do have our a value, stays the same, and so we do have 3. So when we plug into our vertex formula, remember we have A times X minus H squared plus K. We know A is 3. We want to change the sign of the X coordinate of our vertex. We get minus negative 2 become squared. And then we have plus K, which in this case is negative 5. And so this is going to be just minus 5. And we're done. All right, for our last example, we have f of x equals 1/3 x squared minus x plus 2. All right, so the first thing that we want to do is we want to find our vertex. We get negative b over 2a. This is going to be 1 over, 2 times 1/3 is 2/3. And we don't want a complex fraction, so what we can do here is we can see this as 1 divided by 2/3. And remember that when we divide fractions, we want to copy dot flip. And so we get x is equal to 3/2. All right, to go ahead and find our y coordinate, we're going to plug this in. And so we get 1/3 times 3/2 squared minus 3/2 plus 2. All right, if we go ahead and square 3/2, this is going to be 1/3 times 9 over 4. We want to square both top and bottom. We have minus 3/2 plus 2. I'm going to simplify this first term. We can divide by 3 to the top and bottom, and we get 3/4. And I want to go ahead and write everything with a denominator of 4. So the middle term, I want to multiply it by 2 over 2. We get 6 over 4. And my last term, I want to multiply by 4 over 4. And we get 8 over 4. If we go ahead and combine all of this, we get 3 minus 6 is negative 3. And if we add that to 8, we get 5. We still have a denominator of 4. And so my vertex, after all this work, and keep in mind, on problems like this, you can go ahead and use your calculator. But we get 3 over 2, comma, 5/4. We do want these in fraction form because our original problem does have fractions in it. This is my vertex, this is my h and my k, and I know that my a is equal to 1/3. We can go ahead and plug this into our vertex formula. So we have A is 1/3. We have our x coordinate of our vertex is 3/2. Remember, we want to change the sign, so we get minus 3/2 squared. And on the outside, we leave it the same, and so we get plus 5/4. That is our formula, or our function in vertex form. All right, that finishes off this part of the video, or the section. In the next section, we're going to go ahead and continue our discussion of this. See you again shortly.